Welcome to our final year project presentation titled Product Mix Optimization of an Online Clothing Store Using Linear Programming.
My name is DANISHA binti DENNEY.
My name is SITI KHADIJAH binti ZAIMI.
My name is HUSNA NABILAH binti JAMRI.
Our supervisor is Dr. MAZNAH BANU binti MOHAMED HABIBOO RAMAN.
For our presentation outline, we will be covering 10 parts.
In today's world, the internet market is one of the primary reasons for all businesses to gradually grow even during this time in global pandemic. Since the business environment is unpredictable and constantly changing, corporations must improve their operations and strategies that extend from the provision level to the top users. Obtaining the right amount of product mix is one of the key elements for an online clothing store to strive further in the near future. Hence, linear programming can manage the issue of the allocation of limited resources in the most ideal way. According to Molina, not all business owners have a stable financial management capacity. At the beginning stage of their businesses, they were unable to estimate the total supply cost at minimum level as they implemented the trial and error technique. This leads to an inability to achieve a maximum profit that improves the efficiency of the business. Thus, the issue addressed here is to evaluate the optimal product mix that the business owner of an online clothing store should be obtained by applying linear programming technique. Our research is aiming to minimize the cost of the clothing product mix in order to gain maximum profit using linear programming as well as to validate the result of the research in finding the least error using percentage error calculation.
These research findings will redound to society's benefit, especially to the small online business owner to achieve their goal, which is mostly to maximize their business profit by minimizing the total cost of supply. This research will assist business owners to make better decisions without wasting time, effort, and money. This research focuses on the data obtained from a personal interview with an online clothing business owner, and this research was implemented by using QM software. For the limitation, this model can be used only for problems where the constraints and objective function are linear. Apart from that, since COVID-19 pandemic hit the country, any face-to-face activities should be avoided at any cost. Therefore, all the data were obtained from an online interview. There are a lot of applications of linear programming in the real world. In 2014, Yao Chin-Saw et al. Aimed to put forth the linear programming techniques by carrying out capacity planning in a textile enterprise in Istanbul. Mobante in 2017 used linear programming to optimize the product mix and increase the profit of a textile manufacturing companies in Utopia. In 2018, Molina determined the product mix optimization at minimum supply cost of an online clothing store. Finally, in 2020, Shakirullah et al. Formulated linear programming to maximize profit and minimize cost of an apparel industry in Bangladesh.
Now we will move to methodology and implementation. The flowchart is as follows. As shown in the flowchart, the first step for constructing the linear programming model is by defining the problem. Our research proposed solutions for an online clothing store to minimize the supply cost of clothing in order to achieve maximum profit using a linear programming model. Secondly, the model adaptation. The basic elements of linear programming models that have been identified are the objective functions, decision variables, and constraints. For the objective functions, we seek to minimize the supply cost and maximize the profit of clothing, while the decision variable to the problem of this research are the demand and supply. Then, we constructed the constraint consisting of the minimum number of pieces to be purchased, maximum number of pieces available for free shipping, demand, minimum number of pieces to be sold to customers, total number of pieces to be sold to customers, number of pieces purchased from the supplier, and the non-negativity constraints. When the problem definition and the constraint have been identified, we key in all the data in QM software and the solutions obtained are to be implemented as the result. After validating the result, the solution can be implemented.
This graph illustrates the comparison on the actual product mix and the suggested product mix optimization of the online clothing store. The blue bar, which indicates the actual product mix used by the store before this only purchased 21 pieces for all types of clothing and sold the same quantity to their customers. Meanwhile, the orange bar, which indicates the suggested product mix optimization, shows that the store should purchase a total of 61 pieces of satin blouses, 109 pieces of satin dresses, and 104 pieces of satin skirts to obtain a total cost minimization of 9,005 ringgit per month compared to the actual total cost, which is 9,164 ringgit per month.
For the profit maximization, the figure shows the comparison of the actual total profit per month and the suggested total profit maximization per month. It can be seen that the suggested total profit per month for all the products is 13,115 ringgit, higher than the actual total profit per month, which is 11,760 ringgit. If they follow the suggested optimal product mix optimization using the linear programming technique, the online clothing store is able to gain an increase in profit for about 1,355 ringgit.
Finally, we will validate the results obtained. Validation is a documented process by which a system or procedure fulfills a certain number of requirements. This research used the percentage error calculation for validation. The formula is as follows. The accepted value is the actual value obtained from the actual data of the business, while the experimental value is the suggested value obtained from the QM software. If the percentage error is near to zero, it signifies that the value is extremely near to the desired one and have a high accuracy, which means the suggested value is reliable. The percentage error for cost minimization is 0.0174, and for profit maximization, the percentage error is 0.1152. From the percentage error calculation, the accuracy for cost minimization is 98.26%, while for profit maximization is 88.48%.
This research demonstrated the ability of linear programming as a quantitative tool commonly used in managerial decision-making to evaluate the optimal product mix by considering an online clothing store in Malaysia as a case study. By comparing the actual value from trial and error method and the suggested value gained from linear programming method, the owner of the online clothing store can reduce a total monthly cost by 159 ringgit and be able to gain an increase in profit about 1,355 ringgit per month if they followed the suggested optimal product mix optimization. It is proven that the linear programming method is far more efficient than the empirical trial and error method, as the percentage error for cost minimization and profit maximization are near to zero and have high accuracy, then the suggested values are reliable. Therefore, it could be concluded that the entire objective for this research has been accomplished, as the optimal product mix obtained using linear programming method has minimized the total supply cost, maximized the profit gain, and the accuracy of the method have been validated.
Here the recommendation for future research. For future works, the analysis of product mix optimization could be solved by using either the Big M or two-phase method. Computer algorithm could also be cheap in helping to find optimal solution. Hence, it is recommended to build in electronic application with graphical interfaces that could be easier for administrative owner to process their data to make decisions. This research could be further extended with regard to the varieties of apparel such as jeans and scarves in accordance with business target market. Several criteria such as the cost of production and the cost of savings also need to be observed, as the more the number of constraints, the more accurate the result could be. Since businesses could record their monthly purchases and sales, they could forecast their sales using any mathematical or statistical models. This research will expose business decision makers to the benefit of switching to a model-based decision-making process which is more accurate and objective.